Welcome all. So today this will be the first part of a new series that I am going to start as I promised in one of my lectures earlier, and it is about microservices, and this is the part one. It is about getting started. So if you like this video, please subscribe to my channel and share it with your friends and like-minded people and put your valuable feedbacks. So what are we going to learn in this topic today? What are the topics that will be covered in this lecture? They are what are microservices, microservices architecture definition, microservice characteristics, e-commerce application with microservices, and why microservices and some benefits of using microservices before concluding our lecture. So what are microservices? A microservice, I will read out from the slide straight away and then we'll explain later. A microservice is a service with one and only one very narrowly focused capability that a remote API exposes to the rest of the system. Okay. And it's also an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms, often an HTTP resource API. So that we'll learn later in a e-commerce application that it is known as the gateway API. Okay, then what does the microservices architecture refer to? The term microservices can also be used to describe an architectural style for an entire system consisting of many microservices. Microservices as an architectural style is a lightweight form of service-oriented architecture where the services are tightly focused on doing one thing each and doing it well. Mark the word, just doing one thing each. So one capability it must possess and do it well. Okay. So some of the characteristics, we will talk about 6 characteristics and explain them in a bit later. The first characteristic is a single responsibility for capability. Then comes the individually deployable characteristic. And the microservice consists of one or more processes, has its own data source, and they are replaceable and can be maintained by small teams. Now, we'll come back to the explanation of these characteristics a bit later, and let's go to the example e-commerce services, microservices. And the e-commerce application that we see in daily life of a shopping cart, they could be, they could be written with microservices such as shopping cart microservice, product catalog microservice, a price calculation microservice, and there could be 2 more microservices in an enterprise or big real life application, such as the recommender microservice and the shopper tracking microservice. Okay, so here in this figure one, we see the example of an e-commerce microservices. They consist of this API gateway, which is also a microservice, and there are 3 more microservices shown over here in this slide: shopping cart microservice, a product catalog microservice, and a price price calculation microservice. So let's understand each of these parts in sequence. We'll come later in the next slide about the recommender and the shopper tracking microservice. To get a feel for how a microservices architecture works, let's look at an example. Now, a user of an e-commerce website adding an item to their shopping cart. Okay, so let's see how it all works, what the workflow is. Now, from the viewpoint of the client-side code, a request is fired to the backend system via the API gateway. So request to add an item to the cart. And finally, the API gateway responds by updating the cart and with the price with any discounts. Okay, this is the simplest interaction shown in the figure one. Now, what happens in the background? So the interesting part is the interactions taking place behind the API gateway microservice to fulfill the request. To add the new item to the user's shopping cart, the gateway uses a few other microservices such as these three. Each microservice is a separate process, and in this example, they communicate via HTTP requests. The request to add an item to the shopping cart is divided into smaller tasks, each of which is handled by a separate microservice, which we have seen. The API gateway microservice is responsible only for acting as a cursory validator for the incoming request from the user. So once this request is validated, the work is delegated to first to the shopping cart microservice like this, with this arrow pointing downwards to the shopping cart microservice, and then to the price calculation microservice like this. Okay. The shopping cart microservice uses another microservice, which is the product catalog microservice, to look up the necessary information about the item being added to the cart through its product catalog data source. Now, all of these services have their own data sources. Okay, whereas this one doesn't have. Okay, the shopping cart then stores the user's shopping cart information in its own data source and returns a representation of the updated shopping cart to the API gateway. So it returns a updated shopping cart with the shopping cart to the API gateway. For performance and robustness reasons, shopping cart will likely cache the responses from the product catalog microservice. The price calculation microservice uses the current business rules of the e-commerce website to calculate the total price of the item in the user's shopping cart, considering any applicable discount. And it actually puts the updated price calculation to the shopping cart so that the API gateway can respond with an updated cart and price. Okay. So let's now see the next slide, which also shows the recommender service and the shopper tracking microservices. Okay, the recommendation engine in the recommender microservice updates its internal model to reflect the fact that the user has shown a high degree of interest in that product. The tracking service, the shopper tracking microservice, records that the user added the item to their cart in the tracking database. This information may be used later for reporting or for other BI purposes, business intelligence purposes. Neither of these actions need to happen in the context of the user's request. They may as well happen after the request has ended, when the user has received a response and is no longer waiting for the backend system. So you can think of these types of actions as side effects of the user's request. Okay, because they aren't direct effects of the request to update the user's shopping cart. They are secondary effects that happen because the item was added to the cart. Okay, so this figure 2 zooms in on the side effects of adding an item to the cart. Now the trigger for these side effect is the item added to cart event, which is fired by the shopping cart microservice when the user wants to add an item to the shopping cart. The two other microservices, these two microservices, they subscribe to the events from the shopping cart and take the necessary actions as events. Which are the events? Item added to the cart event. These two subscribers react to the events asynchronously. This is asynchronous reaction. Okay, that is outside the context of the original request. Okay, so the side effects may happen in parallel with the main handling of the request or after the main handling has completed. Now let's come back to the explanation of the characteristic that we bullet listed earlier. Now, as you can see, the first one was, again recollecting, it was a single responsibility for capability. So a microservice is responsible for one and only one capability in the overall system, which we have already told, we can break this statement into two parts. A microservice has a single responsibility, and that responsibility is for a particular capability. The single responsibility principle has been stated in several ways, and one traditional form is a class should have only one reason to change. Like for the class, the single responsibility principle is like this. Although this way of putting it specifically mentions a class, the principles turns out to apply beyond the context of a class in an object-oriented language. With microservices, we apply the single responsibility principle at the service level. Okay, so there are two types of capabilities that a microservice can perform. There is a business capability, which is something the system does that contributes to the purpose of the system, like keep tracking, keeping track of users' shopping carts or calculating prices. Okay, but there is also a technical capability. So business capability and a technical capability, which is technical capability is that several other microservices need to use, which is a particular technical capability, like integration to some third-party system, for instance. And these technical capabilities aren't the main drivers for breaking down a system to microservices. They are only identified when you find several business capability microservices that need the same technical capability, like integration to the third-party system. Now, the second one is individually deployable. A microservice should be individually deployable. When you change a particular microservice, you should be able to deploy only that changed microservice to the production environment without touching any other part of our system. In the example shopping cart e-commerce application that we have just seen, whenever a change is made to the shopping cart microservice, you should be able to deploy just that shopping cart microservice. Meanwhile, the price calculation microservice or the recommendation microservice or the product catalog microservice should continue working and serving the user requests. Okay, without any hindrance, without any um, I mean failure. Being able to deploy each microservice individually is important because in a microservice system, there are many microservices and each one may collaborate with several others. At the same time, development work is done on some or all of the microservices in parallel. So if you have to deploy or groups of them together, the deployments would quickly result in infrequent, big and risky deployments, which you need to avoid at any cost. Okay, so that you are able to deploy small changes to each microservice, frequently resulting in small and low risk deployments, and consists of one or more processes. There is a third point in the characteristics. A microservice must run in a separate process or in separate processes, or if it is to remain as independent as possible of other microservices in the same system. The same is true if a microservice is to remain individually deployable. Now, breaking that down, we have 2 points. Each microservice must run in separate process from the other microservices, and each microservice can have one or more processes. Now, consider the shopping cart microservice again. If it ran in the same process as the product catalog microservice, that would mean a tight, undesirable coupling between the shopping cart microservice and the product catalog microservice. One might cause downtime or bugs in the other. Now consider deploying a new version of the shopping cart microservice, in which case just the shopping cart code has changed and you need to deploy the new version. Now suppose they are working in the same process, my shopping cart microservice and the product catalog microservice, then they both have to be deployed together. Whereas there is no need for product catalog microservice to be redeployed as it has not changed. And if that happens, this goes directly against the microservices being individually deployable. So, and another thing is that a microservice can have two or more processes so that it can implement everything such as the data storage and the background processing it needs in order to provide a full capability to the system. And why they should have their own data source or data store? A microservice owns the data store where it stores the data it needs. This is another consequence of a microservices scope being a complete capability. So just to make it independent of other microservices, they should own their own data store. Okay. So the fact that each microservice owns its own data store makes it possible to use different databases, different database technologies for different microservices depending on the needs of each microservice. For example, the product catalog microservice might use SQL Server, Microsoft SQL Server to store product information, and the shopping cart microservice, on the other hand, might store each user's shopping cart in Redis or in, say, document database such as MongoDB. And the recommendations microservice might use an Elasticsearch index to provide recommendations. Okay, fine. And and regarding the small team, it can be maintained by the small teams, and which are small enough, like around five developer team, which are able to maintain a few handful of these microservices, and they should be replaceable. So their code, if needed to be changed due to some messing up in the existing microservice, could be done in a short period of time because of it being a less amount of code. Okay. Now we have gone through this one. We have gone through the example of e-commerce microservices. So let's come to why microservices are needed. If the characteristics as discussed previously for a system built with microservices are adhered, they result in a system which is malleable, scalable, and robust, and allow a short lead time from start of implementation to deployment to production. Now, these benefits are realized because when done well, microservices enable continuous delivery, allow for an efficient developer workflow because they are highly maintainable, are robust by design, can scale up and down independently of each other. Now, let's talk about all of these points one by one. So, let's talk about the enabling continuous delivery. The microservices architectural style takes continuous delivery into account. It does so by focusing on services that can be developed and modified quickly, can be comprehensively tested by automated tests, can be deployed independently, and can be operated efficiently. These properties enable continuous delivery. Okay, but this doesn't mean continuous delivery follows from adopting a microservices architecture. On the other hand, the relationship is more complex. Practicing continuous delivery becomes easier with microservices than it typically with more traditional SOA, non-microservices architecture. If microservice deployment isn't automated, the amount of manual work involved, you can imagine, will be overwhelming. The amount of manual work involved in deploying a full system of microservice will simply be overwhelming. And about the high level of maintainability, from a developer's perspective, several factors play a part in making microservices maintainable. So each well-factored microservice provides a single capability, not two, just one capability, as we have already told. A microservice owns its own data store. No other service can interfere with the microservices data store. Thus, combined with the combined with the typical size of the code base for a microservice means you can understand a complete service all at once. And well-written microservices can and should be comprehensively covered by automated tests. For an operations perspective, a couple of factors play a role in maintainability of the microservices, such as a small team can maintain a few handfuls of microservices. Microservices must be built to be operated efficiently, which implies that you should be able to easily determine the current health of any microservice, and each microservice is individually deployable. And it should follow that issues in production can be discovered in a timely manner and be addressed quickly, such as by scaling out the microservice in question or deploying a new version of the microservice. So a microservice is how they are robust and scalable. A microservices based architecture, distributed architecture, allows you to scale out each microservice individually based on where the individual bottlenecks occur. So furthermore, microservices favor asynchronous event-based collaboration that we have seen with the recommender microservice and the shopper tracking microservices in the e-commerce application just a while back. And they stress the importance of fault tolerance wherever asynchronous communication is needed. So when implemented well, these properties result in highly available and highly scalable systems. So let's see some the summary of benefits of using microservices. So since they are loosely coupled, a bug in any one or more of the service doesn't take down the entire system, saving a lot of precious time for the operations team and for the users. As these microservices are individually deployed, hence they are more frequent and they have small and low risk deployments they produce. And they are easy to develop each microservice as they have a small code base and easy to maintain robust and scalable architecture. Now, we'll finish it with uh, a concluding remark on uh, what we have learned in this lecture. In this lecture, we have defined microservices and microservices architectural style. We have discussed a shopping cart e-commerce application that has a few microservices and how they work together to deliver response to a user request using API gateway microservice. And we have also defined and explained the 6 characteristics of microservices that result in answering why they are needed. And finally, we enlist a few of the major benefits arising out of using the microservices in an enterprise app. That's all.